Hello everyone, welcome to my talk. My name is Roller Angel. I'm a senior systems administrator. I'm based out of Florida in the United States. This is about automating my lab. I use Ansible to set up everything and then Salt to keep it going and maintain it over the long term. In my job, you really learn the importance of managing the configuration of your systems and understanding how careful you need to be when you're making changes. It's good to have a good workflow when you put changes into production. We do change management system where you talk about what's going to go into it, what could go wrong, how you're going to roll it back if it doesn't work, and how do you prove that the change was successful. So with these tools, it makes it a lot easier to get something tested, working, and then out the door into production and in a way that's reproducible and you can validate it. And then also, I deal with a lot of auditors, and these tools prove to be valuable in that realm because they can do what's called file integrity monitoring. So if you manage the state of everything with these tools, then you can prove that you know the state of these files, and if they were ever to change, that you would have a difference, and you could show that you could log that somewhere, you could send it to a monitored inbox. There's a lot of different methods to take the data from these programs and put it into other areas to solve problems, and you don't have to invent other solutions, because I know sometimes you'll get to the 11th hour and then find out that file integrity monitoring needs to be in place, or else you don't get a pass. And you're like, oh wait, what do we got to do? And then you just realize, no, we've already had it. We can prove, and then you just show that to the auditors and they're fine. So stuff like that makes it nice. So today what we're going to cover, we got a little bit to go over. I like to pack a lot into my presentations. I really want to send you guys home with something that you could take away and go run your own lab. So we're going to cover why you would want to automate. I'm going to go over the lab and even the laptop setup. So this laptop is set up through Salt, and I'll show you how to do that. The lab can actually run the automation tools, and the laptop can just connect into the lab and pull its state directly from there. So I'll show you how to bootstrap a new system, both a new system like a new laptop or even a new lab jail, because this is all about jails and FreeBSD. Because, I mean, if you're going to run FreeBSD, you want to get away from VMs, I would say, from my experience, just because you need more horsepower and more hardware if you want to run VMs, because the first choice you make with a VM, how much hardware am I going to emulate for this thing? And when you make that decision, you're taking that away from the host and giving it to one specific VM, and then you're immediately limiting your possibilities. How many more of these can I make before I got to go buy more stuff? But with jails, you can make that decision way later. You can just keep running jails until you start to see a problem with resources, and then maybe you can decide you need to upgrade something, or you can look into resource controls and try and see if you want to go down that rabbit hole, or maybe just tweak your storage setup, put some new jails on a different hard drive or something like that. Play with ZFS, those kinds. So this is actually ZFS jails. I love ZFS. It's super nice, the built-in native encryption and just the endless possibilities for solving problems. It's a good thing to have. I'm not such a big fan of UFS. I know it is nice, and there are people that really like it, but when it bites you, it bites pretty hard, and it's sad. I mean, it's hurt me a few times where FSCK, and you're like waiting and waiting, and the system needs to come back online, and you're like, what the heck? So I don't ever run into those problems with CFS. Then we'll talk about automating system installation and package setup. When we add a laptop, we're just doing SSH access. So literally going through the installer in FreeBSD, and at the end, rebooting and not touching it again. You go into the jail host, you SSH into your with Ansible, and it starts setting it up. So you don't have to install any tools or anything on it. You just go through the installer, put yourself in the wheel group, create a user, and make sure you leave the default setting with already has SSH running. But then we're going to talk about, so Ansible I use to set things up that don't exist already, right? Because Ansible's really good about, hey, I see Ansible more like I'm the coach now, and Ansible is the player. I used to be the player. I used to have to go through all the plays myself. I used to have to run them all. And now I can kind of be the coach, back up a little bit, and just throw the playbook down and say, run the playbook. Like I know what to expect. You guys need to do exactly what I told you to do, so execute. And then you get the same results every time because there's no human error in the equation. It's, that's what I really like about machines is they don't lie, and they don't, if they make a mistake, there's usually a reason. You can figure out why. But Salt, I like to manage my machine states with Salt because maybe I don't want SSH running on my machine, or I don't want to manage the keys or rotate the keys, leave the keys somewhere, try and come up with a place to run Ansible. So with Salt, you have an agent that you install on the client, and you have a master that you install on the Salt master. And if you run the Salt master inside your LAN, then anything that can talk to it can be controlled by the Salt minion, can all be controlled by the Salt master. And it just makes it really nice because in the background, the keys rotate automatically. A new minion can come and talk to the master and say, hey, I'm here. Where's my state? And the master can have it in its unaccepted keys list. So it's not allowed to see anything yet until the master says, yes, I accept your key, and then it can start to pull its state down. You can go both ways. The client can ask for a check-in on the state, which is nice. You can put that into your logs. You can just run you can do a test equals true, so you can not change your state, but you can ask what should my state be, and it'll output any changes that it detects and what it's going to do. And you can always just save that, email that, put it in a log somewhere, and that way each of your machines has got a record of however often you want to run that, what state it was in at the time, and if it matched what it was supposed to match. But you could do the other way around. You could do from the master and contact all the minions at the same time and tell them, check in. Like, I want you to update your state to whatever changes that may have happened. Okay, so the lab hosts. Like I said, this is FreeBSD 14.2 with ZFS on it. So after I installed it, I just went and needed a couple extra packages. I needed sudo. I'm just using git lite and Ansible. So with those three installed, the only thing I needed to do is go into vi sudo and give the wheel group privileges. Now it's ready to clone. So what is this repository? I've actually built a set of playbooks for you, and that you could use to build your own lab and try this out. So there it is, BSD Programming Workshop, ZFS Jailhost Lab. So that's all I've done today is set up a computer, run these couple of commands, and then I'm going to run the playbook, and it's going to build my lab. So why automate? I don't know about you guys, but so many times I've been up late trying to solve a problem, trying to get Plex Media Server to talk to other services and automate all of them, so if something comes down, it can talk to another thing, send an API call, and make a bunch of magic happen. Well, there's nothing like getting it all working and then it's running for a little while, and then hard drive will die. Or what happened to me was I was running it on an old motherboard, an old AMD processor, like the FX ones from back in the day, because it was just fine. It was just running for a really long time. But at some point, it burned up because it was always on, and it was always working way harder than it probably should have, and it just stopped working one day. And then I was like, oh, geez. And so going to bring that machine back, I figured, oh, this is probably a good time just to rebuild it. Well, those types of scenarios, you realize there was a lot of tricks. You were pretty clever, and you don't remember what you did. You're like, what was the trick to get the sticky bit to go so the folders, when another project, what was it, like this program and this program and this program need to share a directory, but I want them all in the same group, and I can't, oh crap, what was that? And then you start digging through your notes, and you can't find the note, and you always find it like a few weeks later when it's too late. there's the note, I remembered it, But with these programs, instead of sitting there at the computer and solving everything, I like to go to a different computer and pop open a lab computer, drop a lab computer in, and start building a Git repository with the playbook in it. And anytime that I want to run a command to change my lab server, I'll put it into Git, I'll check it into place, I'll go to the lab server, and I'll pull the repository down, and I'll run the playbook. Because then I force myself to never run a command manually. I always have to come up with the command, run it through Git, and sometimes it gets really annoying because it takes a couple extra steps, and it feels, there's the temptation to just go to the command line. It's right there. I'll just type the command. Here, I just need to edit the one file. But it'll just keep coming back to bite you because, oh yeah, I switched the interface to the other interface because, oh, the NAT wasn't working right, it was the bridge network, or whatever it is. There's always some little thing that you do that later you're gonna not remember what the heck it was. And so why automate? Because it's gonna save you from all that, and it'll get you back to your list, right? Like, I don't know about you guys, but I have all of Michael Lux's books. And I haven't read them all yet, but I've read a lot of them, and I wanna read them all. And I wanna go, every time I'm reading one, I'm always putting like, I'm gonna do this at some point, and I'm gonna do that at some point. And you don't wanna just keep stalling on the same projects when you could be way further ahead if you would have just automated the things that you had already learned and stop trying to relearn them, because time flies, and before you know it, you're kicking yourself because you're like, oh, dude, I wish I would have spent more time on this, and I wish I wouldn't have went down so many rabbit holes, and I would have just solved the problem. So what you'll see that's cool with automation tools is you don't have to know all the tips and tricks. You don't have to make everything idempotent. It doesn't have to be super pretty. You could start with shell commands. Literally, you just say module command, and you just want to run this command, then run this command, then run this command. And then at some point, you'll be like, oh, they have a copy module? I should probably just use that. And you can start updating it later, but don't get too hung up on making it perfect. Try and get your project done, and if it bugs you enough times, go and optimize it. But I find myself, every time I get an idea to optimize something and I go fix it right away, I never end up doing the thing that I sat down to do in the first place. So those are some tips about automation I would share with you. So here's the FreeBSD Jails lab. What I did was I just recorded running this playbook that I was just talking about. So I'm going to show you that recording here in a second, but that's my lab. So I got a desk at home. It's got the CPU cooler sitting underneath it. It's always running, and that's a Dell Precision. The cool thing about the Dell Precision is they made them for architects, and they didn't sell a lot of them, and so they offloaded a ton of stock to certified refurbished resellers on eBay. And those guys there's different ratings on eBay, and the 100% refurbished guaranteed one is legitimately a brand new computer. It has the tape on it and everything. It's all brand new. And they just can't sell it as new. So you can get these things for a killer deal. And the cool part about them is they have Xeon processors, and they have 4 NVMe slots. And they're using DDR4, which is a little more affordable. So you can just bump it up to 128 gigs of RAM if you want. Mine came with mine came with I believe 116, and then I bought some 32s to go in it. So I'm up to 96 right now. I just didn't feel like taking out a 16 and putting it on the shelf. I figured let's go with 96 and see where it gets me, and it's been perfectly fine. And then I bought a couple extra SSDs to mirror for the labs. So the one that it came with is for the host operating system, and then the other two are mirrored together, and that's where all the lab data sets are. So this is a different view of it, just to show you. It's kind of hard to see, but that's the built-in Ethernet cord coming out. I renamed that one to Home 0. I renamed the interface to Home 0. I'll show you a little bit in a sec. And then this is a USB-C Ethernet adapter that's got Ethernet coming out of it, and I call that one Lab 0. That goes directly to my ISP's modem. So I don't have any I even bought my own modem, and I don't use any of my own ISP's equipment. I just bought my own modem, I registered it with my ISP, and I plug it into this. And so, and then this access point is radio only. So this black cord coming out, Home 0, goes into the back of here, into the WAN port, and then now I've got any of my devices that connect here get an IP address from the lab, and this red cord coming out is just on an Ethernet switch that's also built into that access point. So I can plug that Ethernet into whatever I want and get it on the network, plug it into another switch if I want to. I seen some advice one time about, I think it was like a YouTube video where they were like, never plug two switches into each other. Don't go from one switch to another switch. And then the idea was, because it's not highly available and one of the switches might break, and then your whole thing will go down. And it's like, and then I'll just replace it. It's not a big deal. It's my home network. I'm not that worried about it. So yeah, you can plug in a switch to another one if you want to. It's fine. I wrote about this in the FreeBSD journal. That's the virtual lab for the BSD programming workshop. That was just command by command. Before I automated it, this is what I came up with it for. I was asked to write an article. I wrote an article about that. This is what I was interested in at the time, so that's what I came up with. And it's been one of the best things that I started on because it just kept evolving, and now it's so nice to have. Like I really, really like it. So what I'm going to show you is I took I'm using VirtualBox to create a couple VMs so that we can kind of emulate what I just showed you, emulate that Precision laptop as VM1. So that's the FreeBSD gel host. I've put 3 adapters on there, just a NAT network, and then another NAT. So the NAT is EM0. The NAT network is EM1. And then the other NAT is EM2, but I didn't rename that one. So this is my rc.conf on the jail, just showing you that I've renamed EM0 to Lab 0, and I've renamed EM1 to Home 0. OK, so these are the interfaces on the jail host. So you'll see up there, there's Lab 0, and here's Home 0, and here's EM2. So it's nice when you rename the interfaces and you do ifconfig, and they just show up with the nice names that you gave them, and you don't have to remember what EM0 was or what EM1 was. EM2 I'm only using for, on this VM, I'm using EM2 just to get internet on the machine while I set up the lab. And then I don't need it anymore. And I'll show you why I don't need it anymore in a minute. And then over here is 2 bridges. You have the Lab 0 bridge, and you have the Home 0 bridge. So in the Lab 0 bridge, there's 2 members. One member is Lab 0, and the other member is E0A gateway. In Home 0 bridge, one member is Home 0, and the other one's E2A gateway. So you might be asking what happened to E1A gateway, because I went from E0A and to E2A. I'll show you in a second. But those are called e-pair devices. So what's cool about FreeBSD jails where they're at today is you don't have to do that weird trick where you're creating another loopback address and sharing an IP stack from the host to the jail and getting confused. You can just use VNet and create separate stacks for each jail. So when you do that, you use e-pair. There's a really nice script in the user share examples called JIB, Jail Interface Bridge. And you just give it an interface, it'll create a bridge for you, and then it'll make one end of the e-pair connected to the bridge, and the other end is connected to the jail. So just imagine it as a physical Ethernet cable. And the bridge, imagine it as a physical switch. And you're just plugging in ports to the switch. And you're running, and the cool part about them is you can take a real cable and plug it into a virtual switch, and then you can take a virtual cable and plug it into the same switch. So then it gives you all kinds of ideas of like how to combine the physical world with the virtual world in a way where you don't have to reimagine it. Like my work's done a lot of changes where we're running everything in AWS, and it's all managed services. And when you go into these environments, it's like, yeah, we do the same thing, but it's different, and we do it different, and everything's different. And you start to, it really gets to the point where you start to lose some creativity because it's not the same. It's not like a real switch with a real cord plugged into it. And this is so cool because it is. It's just exactly the same as a real computer. So if you didn't have to set up 20 computers, you could just jail 20 computers and run those cables into your switches and just be like, just in your mind, it's like you're running your own lab, but you just can't see it. Hopefully we'll get there one day where you could put on these goggles and you could see your lab. I think it would be so much better for training courses. And then you could see the data going between things. And then when the firewall is blocking something, you could just see it stopping. And you'd be like, oh, that's what's happening. But until then, we just have to imagine it all in our minds. OK. So what was that other interface that I skipped? It's a VLAN. So I made a VLAN called LabNet because I needed a device to give to JIB. So JIB would create my LabNet bridge. My LabNet bridge is what I use for E0A update. That's my update server. E0A Salt. That's my Salt server. E1A gateway. So that's where the one went for the gateway. And then now all of those are plugged into the same switch. So that makes it they're all in the same LAN, which is nice. OK. So this is going to be what you see if you go into my gateway jail and you look at its network setup. So there it is, E0B gateway, E1B gateway, and E2B gateway. And you'll see that E0B is just getting an address from the modem or whatever's upstream, or the NAT. In this case, in VirtualBox, the NAT's just a 10.0.0.2.15. But the E1B gateway, it's setting its own address, and it's saying, hey, I'm going to be 10.66.6.1, because I want to be the gateway for this LAN. And E2B is saying, hey, I'm going to be 192.168.66.1 for the home network. And so there it is. There's your lab network. Here's your home network. And there's upstream at the top. OK, now if you didn't catch this earlier, this is a callback to the home bridge. Did you notice there's an Ethernet MAC address on the bridge? Now, this I didn't realize when I wrote the article for the FreeBSD journal. But this is the best thing about building these tools and replacing your devices at home with FreeBSD and actually using it, is you start to try and figure out how would I do this? And how would I do that? And when I've seen that, I'm reading the handbook, and the handbook is like, you can just assign an address to the bridge. I was like, wait, what? Hold on a second. So if I run DH client on my home 0 bridge from the lab, the jail host, now it's a member of the bridge and it's getting its IP address 192.168.66.11 now. And I was like, oh, that's so cool. So now I don't have to use the EM2 anymore. I can get my address from the home bridge, and now my jail host can now be on the same LAN as my home network. And I didn't have to plug in another device. I didn't have to use Wi-Fi. I didn't have to do anything. I just used what was already there and assigned an address to the bridge. And that just blew my mind, because I was like, how cool is that? Like, why wouldn't you let it have an address? Because it's not an actual switch, right? Like, it's emulating a switch, but it's also virtual, and you can just assign an address to it. So I was like, gotta love that stuff, man. So cool. This is very important if you're going to use VirtualBox. When you create a NAT network, and your idea is to use it as, like we're going to use it here, as an actual, I've got a gateway, and it's going to control all the traffic for all the other VMs that might want to talk on that lab network, that home network. You have to set this promiscuous mode to allow all, or the traffic just won't flow. And you'll think something's wrong with PF, or you're like, what? Why is this stuff not working? It's just that. So make sure that's allowed all. And this is VM number 2, the laptop. It's got one device. It's on the NAT network called home network. And if you look at what home network is, you could put anything. 10, 28, 6, 0, it doesn't matter. Just make sure the DHCP server is disabled. There's no check here. Call it whatever you want and assign it to the VMs that you want to be on that network. And that's it. Because this doesn't actually get used by anything, you can control it all in FreeBSD. Oh, and then on VM2, since we want to do display, the idea is to pretend like VM2 is my laptop. And I want to start X and have a GUI and all that with Xorg. So if you change the graphics controller to VBox VGA from whatever it's set to, VirtualBox is going to tell you did something wrong. Probably just because they want you to use their latest driver, and they're assuming you're using some operating system that they support a little more. But if you don't use that driver, you're not having display in VirtualBox with FreeBSD. So just ignore that. Ignore the warning, but set it to VBox VGA. OK, this is the FreeBSD Jails lab. So all you're going to see is that I'm doing DH client to EM2 to get an address, because I haven't done anything yet except what I showed you earlier, just installed a couple packages. So now I'm git cloning that git repository. And then I'm going to cd into that repository that I just cloned and run Ansible-playbook and run the playbook. And it's going to take my fresh installed machine that only had Ansible, sudo, and git, and it's going to set it up as a jail host. And it'll go through every single thing it needs to do. I need the jail service. I need the base.txt from freebsd.org. I need to create some data sets. We're going to load the PF kernel. We're going to rename those interfaces that I was telling you about. This is actually going in and setting up all those names that I set up, the home 0 and the lab 0 and all of that. Once it's done, you're going to have a FreeBSD jail host, and you're going to have two jails. So it's setting up the gateway jail, and it's setting up a salt jail. And then in the salt jail, it's copying these salt states. So I've included in the repository a set of salt states that I'm copying into the salt jail so that we can have something to use to control the state of our machines. So that's it. Now we've got a lab jail, or a lab host with jails. Come on, buddy. OK, this is the laptop. So like I said, sudo dh client home 0 bridge, because I want the jail host to be on the bridge with the laptop and the rest of the home network. So I'm just doing a ping real quick to verify I've got internet. OK, everything's good. And then I'm going to go into the jail host lab, but I'm going into the add desktop to Salt playbook. And then same thing, Ansible playbook. And I run the playbook, but in this case, I need to do lowercase k and capital K. Those are saying I need to provide an SSH password, and I also need to provide a super user password. So when you run those, it'll tell you, hey, you also need SSH pass. So now I'm just going to package install SSH pass. If you try and log in with Ansible to a server that doesn't have a key, it's going to ask you to use SSH pass. So I'm just going to go run that playbook again now that I've got SSH pass. And I just wanted to show you that you might get that. So there's no tricks here. This is everything that happened. And then there you go. So it's using the raw module to install Python 3.11. Then it's installing sudo. It's configuring the sudoers. It's installing Salt. And then it's setting up the Salt minion to talk to the Salt master. So what I want to do now is log into the Salt server, which is from the jail host, you can just jump into the Salt. So I'm in Salt asking it, what keys have you seen? And there's a new key for the desktop, and I just added it. And I told the desktop to come up into its state. So now I'm logging into the desktop, typing start X, and the desktop is configured. So it's that easy. You accept the key, you apply the state, and the machine now is how you wanted it to be, and you didn't have to touch it. You just start X and use it like you would like to use your desktop, which is beautiful. And there you go, just showing you that the desktop actually works. You can auto-size it, and so that means that the graphics drivers are working fine in VirtualBox, and the services that must be enabled. And then just showing you that the internet's working. You can go to websites, et cetera. This is my website, bsd.pw. I try to put notes and links and videos on here. OK. And then I'll just shut down the machine. Yes?
I don't know either Salt or Ansible that well, but I do intend to learn it. Which one needs a server? I think the Salt.
It's Salt.
Salt, right?
Yep.
Is the server part of the lab itself, or is it a distinct thing? Like, where is the server running?
There's a server called, I'll show you real quick. So here's, I'm connected to a VPN right now, right? Open VPN to my house, to that laptop I showed you. Because I have a jail in my house called VPN, and that's what's providing this. And now I can actually log into Salt. So Salt is .2 for me, and there we go. So Salt is actually just a regular jail, right? It's got E0B Salt. It's just a jail. It's at .2, and then it has a bunch of states and user local etc Salt states. And there's all my states. So I've got the base, I've got Bob and DB1 and Gateway and Media Center and OpenVPN and Poudriere and Salt and an update server and a workstation and a bunch of stuff.
So as part of the stand-up for it, you create the Salt server?
Yes, I created the Salt server for you. And that's basically just etcrc.conf. That's basically just these couple lines, right? You've got Salt master enable. And the cool thing about Salt is it can also be a minion of itself. So you can Salt minion enable as well. Because you would also want to manage the state of the server, the Salt server, somehow. So just do it. You don't have to do anything special to do that.
Thank you.
Yep. OK, and then, OK, this is the additional jail. So I've also included an Ansible playbook to add a jail, because you're going to want to add a jail to make more jails for your lab. So all you need to tell it is the name and the number that you want the jail to have. So this one's literally just, and this is how you pass in variables. You're just saying -e lab client host name is update and IP address is 3. And then you run the playbook. It sets up another jail called update, and it gives it the IP address that ends in .3. And it'll do all the same stuff. Start the service, restart the jail, and now when you go into Salt, you check the keys. There's a new key that needs to be added. You just Salt key -A to add the key, and now you can apply the state. So you can go to Salt, you can apply the state. You don't just have to do star, you can do like a wildcard, like update star. I just want the state to apply to that new update server I just added. And it'll go, and now the update server is set up. This update server is a very simple one. It's just Apache, and it caches files for 1 day. And the only path it lets you go to is 14.2-release on FreeBSD. So one of the Salt states, the base Salt state for all the Salt servers, for all the minions and all the FreeBSD machines, is just to change freebsd.conf and change the host to this update server. The reason I do that is because when you're running a lab and you want to update all your servers, being a good net citizen would be to only ask the FreeBSD update server for one set of update files. And then once it gets into your network, you share all those update files with all your servers, and they're not all talking to FreeBSD. You're saving them bandwidth, and it's a nice thing to do. OK, next one. OK, so maintaining and scaling with Salt. As you saw, I ran that Salt state.highstate command. That's how you, from the Salt master, how you would tell the machines that you want them all to check up and apply any state. So a cool thing you can do is you can say FreeBSD_update.fetch, and they'll all go fetch their updates. And like I said, since their update server caches files, they'll only get one set of files from the FreeBSD upstream, and they'll share them amongst each other. And then FreeBSD update install installs all the patches. Here's how you do package updates. You just package.update, package.upgrade. And all your machines are up to date, even your laptop. So that makes it really nice. Instead of, I used to find myself on one machine updating it, and then jumping to another machine and updating it, and then at some point forgetting that I didn't update the media server machine or whatever, and it's falling behind. So this is nice. You keep everything going. You maintain them all. And that's why I really like Salt, because with Ansible, right, you've got to find a place to run it first. And then you've got to think about wherever it's running, it needs to be able to talk to all the other things. So there's got to be some sort of network connectivity there. Also, there's got to be an inventory, and it's not dynamic. There's no way to add stuff to the inventory. There's a lot of tricks for inventory. That's a whole rabbit hole. But what I'm saying is, the machines you're trying to control don't talk to Ansible and say, hey, I just joined the network. Can I be part of the inventory? They don't do that. So you have to go in your inventory manually and make it all nice, and you can add it. It's sure, like if that's how you want to do it, but where are you going to maintain that? And what if you lose that computer that had the Ansible on it? Because you're not managing the state of the Ansible, are you? With Ansible? Are you in the inventory for that? I don't know how you're doing that. But with Salt, that's not a problem. You can manage the Salt server with Salt itself, and the inventory just kind of is a growing, living thing. And then the keys, like, are you putting SSH keys on all these machines, and you're SSHing to them all, and then at some point you need to rotate them? You talk to an auditor and tell them that you leave keys on machines, and to make it easier, you don't put a password on them, or you store the password in memory, or you do some weird stuff. They're gonna bite you really hard. And maybe you can talk yourself out of it, or you can come up with some cool tricks, or you can use the YubiKey and say, hey, the key's over here, and it never leaves here. So someone actually physically has to go to the machine, and we touch the thing. So there's ways around it, which is but I didn't even have to consider any of that stuff really with Salt. It's in my local network, and nothing can talk to it unless it's got my SSH key for that server, and I'm coming in through my VPN. So I've got my VPN protections, and then I've got my SSH key protections. Then I just have to rotate that one SSH key that I use to get on my network, and that's not bad. I could manage that. And then the other cool thing is you can command.run. So I can just say, hey, I want to know the FreeBSD version of everybody. Like, everybody, what's your FreeBSD version? They'll all come back to you and tell you. If you don't want them all if you get too many machines and you don't want them all talking at the same time, you can do batches. So you can do B1, B2, however many you want to do in a batch. And it'll chunk them into batches. So that's super nice. So here's a little clip of those commands running so you can kind of see what they look like when they run. You've got the state.highstate one, calling everybody and saying update, and they all just kind of fly across the screen, and you get a little summary for each machine about like if anything changed. Here's the FreeBSD update fetch, and that's just, you're seeing every single machine got its updates, and then you do the FreeBSD update install, and all the machines are gonna install their updates. And then this is a package update. All the machines were just installed recently, so there aren't any updates. But it'll just show true to show that it did the package update command, and then there are no upgrades. That's why those are just lines. But if there were upgrades, it would show you the old version and the new version, which was installed for each package. And then here's me asking all the machines what FreeBSD version they're running, and they all just come back with the latest release and patch version, which is nice. Okay, Ansible quirks. SSH pass, like you've seen. If you don't want to use a key and you're using passwords, you need that SSH pass program. Start at task equals quotes. As you've seen, every time an Ansible command was running, it had a name. You can take that name and put it in start at task when you run a playbook, and it'll start at that spot in the playbook. And that's really nice for building playbooks, because if you're doing it in a step-by-step manner and you haven't made it idempotent, then you don't want to run all those commands again while you're trying to figure out what you're going to do next. So you just start at task. But then it'll start at task and it'll just automatically go to the end. If you want it to take its time and do one at a time and say, hey, do you want to do this? Yes, no. You can do step. So if you add step, it'll literally ask you yes, no, or continue. So yes is do the one thing and ask me the next one. No is don't do it. And then continue is okay, from now on, just automate. Do the rest of them automatically like you would if I started at task. So that's some Ansible quirks to know about. And then Salt quirks. You can't see this very well, but basically minions returned with a non-zero exit code. Sometimes your minions aren't responding. And you're like, what's going on? In this case, it was the captive portal came on. Well, I was doing something, so I took a screenshot. Just wanted to show you that my upstream internet connection died, and then I asked it to do state.highstate, and one of its things is to check if it's on the latest packages, and it wasn't able to do that, and so the minions were like waiting. It's saying the minion didn't return, and it's saying that it's doing something, and there's a job ID associated with what it's doing, and it spits out the ID. So you can go, the cool thing about Salt is it's event-driven, and it's got this whole event bus. So there's this event bus. Just use the event bus. You can see all the events hitting the Salt event bus in the background. You can see the minion keys that were accepted. You can see when a state apply was finished or when it started. Custom events are really cool to dig into, or orchestration events. So this is the command you run. Salt runs state.event pretty equals true. And then you can grep for whatever you're looking for. Or you can just watch it. You can just leave this up and running and just see what's going on. And when you see stuff happening, you can use Salt to create other triggers and react to those things. And you can do anything that you can imagine with an event happened, and now I want to do something based off of that. So now you've kind of built this ecosystem where all your machines run, and you've given yourself the ability to tap into this thing, and it's literally just a log and monitor of everything that's happening. And once you start to dig into it, people have done some pretty creative stuff with it. So that's probably where I'm going to start digging into next, is figuring out cool things that I can do based off events that are happening on my network. And that's it. So if you have any questions, I'd be happy to go over them. I am SSH'd into my real Salt server right now if you want me to run any commands. And thanks to the docs of FreeBSD, Ansible, and Salt. And then also thanks to this guy. I don't know if you heard of him, Benedict. This was where I first took a tutorial in EuroBSDCon. So I recommend doing the tutorials when you come to conferences, because they can set you down a path that can change your whole life. This did change my life. I was sitting at a help desk. I knew my job very, very well, and been there for almost 10 years, and was just geeking out, doing a bunch of hobby stuff, and going to talks, going to conferences, sharing my ideas. then I just got hit up by a bank saying, we can't find people that know this stuff. There's a good opening, and we would like to see if you're interested. We've seen some of your stuff, and it looks like you know exactly what we need. So I said, sure, and now I've been there for almost 3 years, and it's been an incredible opportunity, and now I'm one of the more invaluable people on the team because you get a lot of people that know a certain thing, that went to school for a certain thing, and they don't see the big picture, or can talk friendly to auditors, or can work together so when you actually play with the stuff and you get your head wrapped around it, you become very valuable to people who have these good jobs and they're willing to hire you. So this has really helped me a lot. So I would definitely recommend that. So now I get to live in the forest with my dogs, and I'm much happier. So I'm trying to take it easy and not ride too many fast machines. I disappeared for a minute there because I had an accident on my motorcycle, but I'm back, and I'll try and stay alive for the next foreseeable future and share.